Signals. The ones we recommend are the TrainTech range of signals. They're mainly from the DC range, not the DCC range. They come as a kit, which might put some people off, but they're actually dead easy to put together. Most of it just push fits together, and there's a little bit of gluing in certain places. The main parts you get are the base, which you can nail to your baseboard, the foot of the signal, the pole, the platform, the head, which comes as two parts. There's various other detailing parts you can add to it, like foam box and handrails, etc. We haven't included those on this kit because we're just going for speed here. Now, as you can see, that is the 3-aspect signal. That's SK4 kit, and you've got the red, amber and green LEDs actually in this signal. Now, what puts a lot of people off with signals is having to actually fit LEDs themselves. You don't need to worry about it on this. It all comes pre-assembled on a PCB, a printed circuit board, and that PCB runs through the whole length of the signal with surface mounted device LEDs actually pre-soldered to the top of the PCB. So you just drop it through the signal and then attach your wires to the bottom. On here you can see we've attached coloured wires, and it's just standard gauge wire, which is an advantage over many of the other products that are available in signals where they use a very thin wire, which is very fiddly. And we've used red for the red, yellow for the amber and green for the green. The black is the common to the LEDs, so that just supplies the negative voltage to each LED. Now, with these kits you can of course use any cable you actually want to, so routing it is quite easy, and any length, so you can make the cable up to the length you actually require. Fault finding is dead easy because you know which one is controlling which LED at the top by the colour coding. And as I said, they come as a kit which looks a bit like this. This is the actual main sprue that you get with the kit. Now you can see they supply the same sprue regardless of which kit you buy. So you've got the 2, the 3, the 4 there, you've got your base, you've got your baseboard base and the various backs that go with that head, and then all the detailing parts around here, and these are the platforms that you might want to use depending on which signal you actually are going to assemble. Now, the actual main part of it, as I said, was the PCB, and that looks like that. And as you can see, the LEDs are pre-soldered to the top there, and that's your solder pads down the bottom. So they are dead simple to assemble, dead simple to wire up, very easy in use. And you know, as far as quality goes, it's a good signal kit. They're quite robust as well, actually. I have knocked one a couple of times, and it hasn't actually disintegrated on me. So there's no real worry about something running into it and actually breaking it in half, which I have had with other signals. Okay, so track sensors. There's quite a good array of different types that you can actually use to trigger the automated signal. Basically, the main two types would be a switch, which is like this type here, which is a miniature reed switch. Put them back there. And then this range here, which all work on infrared light. So first off, we have the reed switch. This has been traditionally used by railway modelers for years now. It's a very simple system. Basically, you mount a reed switch into the track and then hide it the best way you can, and then mount a magnet underneath your locomotive. As the locomotive goes over the reed switch, it actually triggers it to make contact, so consequently you're closing the circuit. Now, because of the way the system's been designed, it needs to pull the sensor input to low, so you will need to basically wire one end to the positive input and then the other end out to the sensor, and then put a resistor in here going down to negative as the pull down resistor. That way, when this actually goes to low resistance, it actually sets the trigger of the sensor to sensor input to the correct voltage and activates the system. There is a major drawback with these. The magnets need to be glued to the underside of each locomotive that's going to use the system, and the drawback with that is that they do then attract all manner of other little bits of detritus that might be on your layout, and that includes track pins. I've had a number of locomotives in where you know the running of it is not that good, and having stripped it apart found that it's got a magnet glued to the bottom, and there's track pins and bits of paperclip and bits of wire and all sorts of rubbish actually caught up in the mechanism of the locomotive. So whilst they were good in the good old days of the old sort of Hornby stuff and Triang stuff, they're not so suited to today's modern DCC systems, where you've got a lot of very, very fine components underneath the locomotive, very fine pickups, lots of very good detail, etc., etc. You can just get something stuck in there and that will actually stop the locomotive working. So we don't actually recommend you use the reed switch system. It does have one advantage: it's not affected by high levels of light, so you know that could be a consideration when actually designing a system. The ones that we do use, however, are this little device here. Now this is a infrared sensor. The great part or design feature of this is that it's literally take the free connections out of the back of the breakout board, which are here, via this header. You don't need to use the header, but it's simpler if you do, and then run them straight out to the positive, negative and sensor trigger input wire on the control board. Now the great thing about these is they are absolutely tiny. If I bring that piece of track in, you can see that that will fit between the rails quite nicely. Now that just needs to be either glued, or as you can see there's a screw hole in the middle, mounting hole in the middle, that can go down through a sleeper. And then you can hide it with an AWS ramp. So it's absolutely brilliant, or some other device. As long as you make a hole in it just so that you can actually see the sensor, which is that little bit in the middle just there, then everything should be absolutely fine and it will work quite well. Very, very good sensors. Very cheap as well. They're not hugely expensive. Any of these sensors are actually, you know, you're talking £1.50 at today's prices in July 2013. So they're not hugely expensive, and they're available from many suppliers. The one we recommend is Hobbytronics. They can be found at www.hobbytronics.co.uk. Great source of electrical components actually. So that's one style. There's a slightly bigger version, which is this one. This does have to have pull down resistors fitted to it, but it's not actually hugely difficult. There are plenty of wiring diagrams online that explain how to wire these up, but obviously it's included in the instructions. And for that to fit, obviously you need to cut a little bit out of the sleeper so that it mounts in the track like that. But as you can see, it's quite well hidden once it's in and ballasted. So a good little device, and it's all self-contained. You've got either tie down holes here for just using a ordinary strap tie down, or you can actually use a screw just to hold it in place. So really, really good bit of kit. It comes as two parts. You get the breakout board and you get the actual sensor. These are available from a company called Syceco. Syceco, good supplier again of electronic components, and you know, you can actually find these in various different places. So that's that style of sensor. We've also got the other version of the independent devices. So this actually is showing the two parts that are actually contained within that device there, and also in that device there. Now what you've actually got is you've got a sender and a receiver. These need to be wired up. Again, it needs to be wired up the same as this version here, with the 4 outputs. Can't see them on that one. There you go. So basically all we need to do is to again wire that up exactly the same as we would that. So that's quite a simple solution as well. And it could actually be mounted on that breakout board, to be quite honest. There's no reason why you couldn't actually fit those onto there. The pins are exactly the same. Then we move on to probably what I would suggest is the preferred method that we're using in the prototypes, which is this one. This is a QRD 1114 infrared sensor receiver. It actually has both parts built into a little plastic shroud, and that fits extremely well into your track bed. With a little bit of shaving off of the sleeper, you can see that actually drops down through there quite nicely, so you can actually mount your board underneath and then poke it up through the sleepers, and with a bit of ballasting around it, it's hardly noticeable, just looks like an ordinary bit of track furniture. So that's the main sensors that we've tested with the system, and they all work admirably. You need to adjust the pot on the infrared ones on the module that's supplied to adjust the actual reflectivity of the sensors, but apart from that, dead easy to set up and to work. Okay, so here we have the signal hardwired into the layout, or onto our test layout at any rate, and as you can see it's currently in the green state. Now what is supposed to happen is that as a locomotive goes past the signal, it will automatically trip it to the red state, and then it will go through amber and then green. I've got it set very fast at the moment just for this video, but in a moment when we run the locomotive you'll see it actually at the normal state that it should be at. So there you go, that's through the various stages. We've managed to build in a fade effect through the software, so it's a bit more prototypical rather than just having, you know, LEDs that go on and off as they change. It actually does slightly dim as it goes through the various stages. The amber's not particularly bright, but that's on the video, but that's the camera, not the actual LED. In real life, where I'm sat now, it's actually very bright. But for some reason the video camera seems to pick this up as a different kind of luminosity per LED. So that's the LEDs on the signal. Now looking down from the top of the track, you can see that that is the sensor mounted on a piece of ordinary Vera board. You can get this Vera strip board from most good model shops or electrical supplies such as Rapid. Basically we've got the sensor mounted in the middle of the track. Now you can actually see that white glowing LED. That's actually the transmitter transmitting the infrared. Now obviously the camera can pick that up, your eyesight will not. Okay, if I look down at that I cannot see anything at all. Now the idea being that as soon as you create some kind of reflection through that sensor, and you can do it with your finger, it will actually change the signal state. Now that's mounted just past the signal, so the idea being as the locomotive approaches from this direction here, it will actually go across the sensor, trips the signal to red, and then carries on in its normal direction down through the line. The idea being that after a preset amount of time which you control through trims on the actual main board, the lamp will then, or the signal sorry, will then go from the red state to amber. Now the idea being that a train can, or a driver can, drive through an amber light. All it's doing is telling him that the next signal is at stop, so he can proceed with caution. So if he does go through that, or if the locomotive does run through that red amber light, it will instantly change to red, because obviously another locomotive has entered that block. You don't want another loco entering in after it. After the time has elapsed for the amber light, if nothing has interrupted it, it will automatically go to green, and then the system is actually effectively in reset. Now obviously you need something to activate the track sensors, so what we've done here is just stuck a small piece of white label. It's just general stationary labelling. Make sure you clean the bottom of the locomotive with a bit of white spirit first, or better still track cleaning fluid, or something like lighter fluid, or what else could you use, isopropyl alcohol, any kind of cleaning system. Just get rid of all the grease and dirt that may have accumulated under the loco, and then basically just apply that label. That is enough to trigger the signal. So let's see the system in action then. I'm just going to reset the signal manually. So it's now on green, and our locomotive is now heading on round the track, approaching our signal, and passes by and instantly trips the signal to red. Now on the next rotation, obviously that signal still being at stop, the train will need to pull up in front of it. Now what we've got here is what they call the brake on DC system. What's happening is the locomotive is now automatically going to stop in front of the signal. This is done by transferring the DCC signal into DC. So when the chip detects DC current, it automatically stops the train according to its deceleration rate, as set by the necessary CV, and the acceleration rate is also controlled by its relevant CV. So that's basically it. I'll do a bit more of a in operation video now, and I'll turn the sound on the locomotive so you can actually see a bit more of what's going on. here where the brake on DC is engaged and pull the locomotive to a stop. We get a caution clear, so here we go, off again. What I'll do is I'll now drop that loco down to 0. So we'll stop it on the other side of the layout. And then after the predetermined time, as I say, which you set with the trim, the signal will automatically change to amber after the amber state. And then we have green clear to go. So let's just bring the loco up to, I think I got it at a setting of 40 for speed on this particular chip. So I can actually engage 40 on here. Bit tricky because I'm using a Dynamis, which doesn't have the best control in the world. Just wait for the locomotive to start up. Accelerate and through the signal it goes. Automatically drop to red. And there we go. Okay, regarding the brake on DC when running under DCC, we know we've got our track sensor there for the signal. If we pan back round here a little way and up the line to there, we can see there's another sensor mounted in the track there. Okay, now that is the sensor that trips the brake on DC. So effectively that track section from that point there, where the two insulated rail joiners are, so if I can zoom in on that, give you a better view. There you go, where those two insulated rail joiners are there, all the way back to where that other sensor is, and then about a locomotive's length. Okay, it's roughly one of those curves there, which is a radius 3. Now the reason for that is you need the locomotive completely to enter the section before, just pan back round from here a second, you need the locomotive to enter that section before that sensor trips, so the locomotive must be completely in the segment. Okay, so it goes right back round to about over there. Okay, why do we need that? Well, the simple answer is that that section between the two insulated rail joiners is actually wired up separately to the DCC bus. Now what I mean by that is that the power going to that section is via a relay mounted in the actual device. Now what happens is that when that relay flicks over, it changes the power from ordinary DCC to DC, hence you get the braking. If the locomotive is actually crossing between a DCC section and a DC section, you'll get a short. The whole system will shut down. So what you need to do is to make sure that there's at least a piece of track ahead of that sensor that is as long as your longest locomotive, not train but locomotive, the actual engine itself. That will then enable the locomotive to enter in and it won't then short out. However, there is a bit of a caveat to that, and that is that if you use coach lighting you will still get a short circuit. Okay, so again it's not suitable for that either. We've come across a number of issues with brake on DC, and that is why that particular part of the module is not actually going to be put into the final commissioned device. What we intend to do is actually offer it with a number of shall we say disclaimers that state that you need to be aware of these running issues, because there are so many variables involved in brake on DC that it's not possible to actually make it as a, if you like, commercial product. For instance, if you use a Bachmann sound chip to class 37, it doesn't work under brake under DC. If you use a simple Bachmann chip, it will. If you use a lock sound chip, it will work. Then we get a bit more confusing. If you use a gauge master or a DCC concepts decoder in your locomotives, believe it or not, the actual DC voltage needs to be the other way around. So you actually have to wire all of your bus the opposite way round and all of your DC brake section the other way round. It's fairly easy. You can just change the wires around, fit a switch. We did look at putting a switch onto the main thing, but that just brought other complications. So there are a lot of disclaimers that go with the brake on DC function, but the actual basic signal controller, where you drive the locomotive and don't have the automatic stop, is what will be available hopefully if we go to market with this product. As I say at the beginning of this video, we do recommend you use TrainTech signals. They're so cheap, come in kit form, dead easy to put together. You know, a child could do it. It's not going to be that difficult. It's literally just push the bits together, a bit of gluing here and there, and job's done. And very easy to solder up and connect. So you know, it's obviously the signal to go for. We looked at various other brands, but they were just, it was just too much effort to try and get them to work in. The wires were too thin, it was all fiddly and not particularly nice, so we suggest the TrainTech signals. And basically that's it really. So if you want to know any more information, there is another video on here which actually just shows the operation of it, and there's a huge bunch of text below that explains everything that I've said in the video, more or less. And if you're still not quite sure or want to implement this yourself or are interested in actually doing something like this yourself, then just get in contact. You can email me via YouTube. Please be patient. I don't read my email every day. I don't have the time. Too many other chickens to fry. So basically that's it. If you want to get in contact, then see below, and hope you found that useful. Cheers. Bye.